In this video, we're going to take a look at how to sketch a spline. Let's go ahead and start a new sketch on our top plane and take a look at the splines available to us. Now, there are a few other types of splines, but in a 2D sketch, we have a spline, style spline, and an equation-driven spline. Now, for the context of the surfacing tutorials, we're only going to talk about spline and style spline. But let's take a quick look at equation-driven spline, just so you're familiar with it. You have different ways that you can define your spline based on an equation. You can use a parametric equation or an explicit equation. For example, if we're talking about sine of x and we have a range from 0 to 10, you can see that a spline is created using a sinusoidal curve from 0 to 10. So it's evaluated with x being a range of 0 to 10. So for the context of what we're talking about, we're not going to be using equation-driven splines, but just know that it is an available option and it can be used if you are defining certain types of geometry that require an equation-driven spline. Let's take a quick look at how to define a spline, and then we'll go back and take a look at a style spline. A spline is defined by its endpoints and its midpoints. Each of those points can be controlled with a handle. Let's simply start by clicking at our origin and then click somewhere else out in space. To end the spline, I'm going to hit the escape key. Now on the screen, it looks like just a simple straight line. And if we grab the endpoint, it stays as a straight line. But you'll notice that as soon as we grab that endpoint or anywhere on the spline, a gray arrow appeared. Now, until you activate this by selecting one of its available options, it's going to remain a straight line between the 2 points. As soon as we move this handle, we've now introduced some curvature based on this handle. There are 3 ways that you can adjust this handle. You can grab this set of arrows, which will allow you to alter the angle. You can grab this single arrow on the end, which allows you to alter the weight or the dimensional value that's given to this. If you grab the endpoint, it allows you to do both at the same time. Now, as you can see on the left-hand side, we still have a gray set of handles. That's because we haven't activated it yet. So the curvature is only going to be based on the original handle that we're moving. As soon as we activate this, now both of these handles are introducing curvature. If we right click on the spline, we can do something such as show curvature combs, show the minimum radius, or show the inflection points. Let's go ahead and show the curvature combs. This gives you an idea of the radius of curvature of the spline you've created. As you can see, there's a point here where there's an inflection where it goes from concave to convex. Now, the curvature combs are very important when we're talking about creating surfaces. If you have any spots in your curvature comb that have quick changes in geometry or dips or different inflections where you don't intend them to be, that can often be reflected in your surfaces as imperfections or dips. Let's go ahead and right click and insert another spline point. Just insert a spline point in the center. We're going to just drag that around. You can see how that alters the geometry, but until we activate the handle, we're not really introducing any new curvature here. As soon as we activate this handle, you can see that the curvature comb goes a little bit crazy. And this is where you want to be careful because we're starting to introduce a lot of extra curvature into our spline. Now, I like to call this tension. We're creating a lot of tension in our spline. At any point in time, you can go back and you can delete these extra points, or you can relax your splines. We're going to go ahead and display our control polygon. So you can see the control polygon is added as lines or endpoints that are coincident or collinear with the handles. So it's just a different way that you can define your spline by using these control polygons. Different users like to control their splines in different ways. It's important to note that when we're dealing with these handles, we can also apply relations. For instance, we can grab this handle here. Let's go ahead and display relations. We have a coincident relation, but let's say that we want to create a horizontal relation here. We can go ahead and add a relation for this entity, making it horizontal. We can do the same thing for this one as well. As you can see, once they're defined, they turn black. So we can no longer drag this up or down. We can't alter its angle, but we can still alter its weight. What we can do now is add a dimension and define the length of that handle. So you can see if we make this top one 20, then we've created a fully defined handle for our spline. Now the endpoint can still be moved around in space, so obviously that hasn't been fully defined, but you can do that by adding dimensions, such as a horizontal dimension and a vertical dimension. So this is how you would create a standard spline and how you would control it, also how you would define it using relations and dimensions. Let's take a look at a style spline and let's look at the differences between the two. When you create a style spline, you're creating a start and an end point, but all the points in between are actually going to be a central point for the curvature. So what I mean here is we're defining a line that controls the tangency at that point for our spline. So as you can see, as we're dragging these points around and we follow this imaginary or this dashed line, that we have tangency with the spline that we're creating. Now this is important, and it's also important to note that you can also define the angles between these lines. You can define their lengths. You can snap them to different geometry. So this is a great way to define a very complicated spline, but not introduce too much extra curvature by controlling these handles manually. So if we right click on this spline, we can show its curvature combs. You can take a good look and you can see how smooth the curvature comb is, even though we added a ton of different points for this geometry. Now it's always important that you fully define your splines once you've created the geometry you wanted. Oftentimes when I'm creating complex surfaces, as I'll show you later in the video, I like to leave some of my spline handles underdefined. So I might define its endpoints and I might define things like the start and end curvature, such as making these vertical or making them horizontal, but I might leave a little bit of the geometry in the middle underdefined until I've created that surface how I want it. Then I'll go back and create the geometry, the dimensions, or relations to help define that. One of the really handy things about using the style spline is you already have these construction lines that aid you in creating the fixed geometry or locating geometry. You can always go back and fix these points in space, and that helps you easily define the geometry without having to have all the extra dimensions. Because oftentimes when you're creating consumer products or complex surfaces, you don't have accurate dimensions for some of the curvature that you're creating. And maybe you do have accurate dimensions, but you don't know what it is yet. So you need to kind of tweak these around manually until you've created a geometry. So the style spline is a great tool, and it was introduced in 2014, so it's not available to everybody. So if you're using 2013 or older, you don't have this style spline option yet, but you do have the standard spline with the control polygons that'll allow you to define these handles a little bit easier.